Hello viewers, welcome back to our YouTube channel, and today we are going to continue with our series of quantitative techniques. This is a CPA level 1 paper, and we want to look at the last part of chapter 5, that is to do with the curves. And we want to look at curves as a way of presenting data. And once we are done with that, we will move to our chapter 6, where we shall look at the measure of central tendency or measure of location. Now, in the previous video, we looked at the frequency polygon, and we want now to start on the curves that we have as far as data presentation is concerned. And the first one that we want to start with, we said we are going to only look at two curves, the cumulative frequency curve, or what we call the Ogive, and then the lens curve. So let's start off by looking at the cumulative frequency curve. So the first one is going to be the cumulative frequency curve, or what we call the Ogive. Of course, an Ogive is drawn with the cumulative frequency plotted against the upper class boundary of the relevant interval or relevant class. So the cumulative frequency curve is used to represent the cumulative frequencies for each of the classes. And as you've known that at some time it can be called an Ogive, and it is just a graph that represents the frequencies for the class in the frequency distribution. So an Ogive is a graph that represents the cumulative frequencies for the classes in the frequency distribution. For the classes in the frequency distribution. And of course, this kind of graph allows us to read off numbers which are either below, or what you call the less than, or greater than, or the numbers which are above a specific value. So that's what the cumulative frequency distribution allows us to do. It allows us to read off numbers that are below or above a specific or a specified value. So for you to draw a cumulative frequency curve, the points are going to be joined with a smooth curve, and of course these curves can be used for estimation purposes. So it is going to be a curve. We are not using a straight line, or we are not drawing lines with a ruler as we looked at in the frequency polygon, but we join points using a smooth curve. So ideally, the frequency distribution in the in that table when we are given with a data set and they have told us that we represent that data maybe in frequency distributions, we find that these frequency distributions shows us the number of items in each of the classes that we have. That's what the frequency distributions tells us. But it does not directly tell us the total number of items that lie above or below a specified values of the distribution. So when we represent this data set in frequency distribution, we can't, it tells us the numbers that are within that certain class or certain interval, but they don't tell us that if maybe I'm looking at how many observations are above 50. So it doesn't tell us that when we represent the information in the frequency distribution tables. So because we can't do that, then this cumulative frequency curve is the one that helps us to do that job, to be able to identify the numbers or the total number of items that are going to lie above or below a specified value of the distribution. So the cumulative frequency distribution is the one that will tell us the list of the total number of items that are either below or above a specified value. And of course, these values are either going to be the lower class boundary or the upper class boundary. So it helps us to express these numbers into what we call the less than or the more than. In other words, when we are expressing these values that are above or below, either being lower class boundary or upper class boundary, we will find that we shall have two types of ogives that will come out of that kind of argument, whereby we shall have those that are falling within the less than ogive and those that are going to be falling into what we call the more than. The more than ogive. And this is basically the lower class boundary or the upper class boundary. That is just what falls in which one depends on the question that has been given to you by the examiner. So I want us to understand how can we be able to maybe draw a less than ogive. Just to know, when you are given, most of the times when you are given in the questions that we do, most of the times we do what we call the less than ogives, most of the times. But I want us to look at, just understand what is within the more than and what is within the less than, because the whole bottom line that the whole focus is to understand how we can be able to draw any of them, or just to draw these two. So once we understand what they are, then we can be able to pick a practical question and we try to solve and understand how we can be able to draw an ogive. So let's look at the less than. The less than ogive. I'm using ogive because it's kind of short. So a less than Ogive, it shows, let me write, it shows the list of items that lie below a given specified value. Normally the upper class boundary. So it is going to be drawn by plotting the less than cumulative frequencies against the upper class boundaries of the respective classes. So the points are going to be joined, as I said, we join these points with a smooth curve. And it is all about getting the upper class boundary. Here we are now focusing on the upper class boundary of each of the classes. Then for the other more than, we shall be looking at it a little bit later, but for it, it is going to be taking the lower class boundaries. So we need now to look at, of course, the steps. They are the ones, the steps we follow, they are the same. We follow the same procedures. Of course, the procedures are just simple for us to, you'll be given the classes, then you will need to get the class boundaries, and then you'll be able to compute the cumulative frequency. Of course, the less than Ogive or the less than cumulative frequency graphs, they are used to represent how many values are below a certain upper class boundary. So what happens is that you can be given a certain upper class boundary. Then we want to know how many values are going to be below that given upper class boundary. For example, if let's say you have been given data that relates maybe to number of scores for the students, they may give you a certain score, and then they tell you how many are less than that. If let's say the class boundary was, let's say 11, let me just say maybe 11.5. That was maybe our upper class boundary. So they tell you how many values are less than that. So it is this less than cumulative frequency that will give us the number of values. So what you do, you draw the curve, then you go to this, you locate this 11.5 from your horizontal axis, and then you draw a line until it meets the curve. Then of course you draw the horizontal line going to the cumulative frequency, so that you can be able to pick the value that corresponds to that value, as long as those two lines meet. So you draw a line, it will be just like, we can have a graph like this, maybe it is like that. Then they tell you, of course, the class boundaries are going to be on the horizontal axis, and then on the vertical axis, we are going to have the cumulative frequency. So you draw a line from this value they have given you to you. If let's say it is 11.5, if it is around here, then you move until it touches the curve, then you move horizontally and you read the value that is here. So the value that is here will be the number of those values that are going to be below that certain value they have given to you. So allow me now explain the more than cumulative frequency curve. Then once we have gotten the difference, then we can be able to get the general steps, and then we pick a practical question so that we can illustrate that as well. So let's look at the more than Ogive. Of course, this one, it lists items. It lists items that lie above. It lists items that lie above a given value, which is the lower class boundary. So they give you a lower class boundary, and then they tell you a lower class boundary of a given class, of a class. So they will give you a lower class boundary of a certain class, and then they tell you to give them how many numbers are above that value. So this more than cumulative frequency curve, it is used in situations where most of the situations they can use is maybe if you are looking at the lifetime, the length of the lifetime. Maybe it can give you maybe the lifespan of a light bulb. So they can tell you to if maybe they are carrying out some testing in the lifespan of the different bulbs, then of course the frequencies, they will show the number of items that will still be there at any period that they have estimated, any time period that they have at a certain time, at a certain point in time. You find that maybe they can say, okay, let's look at the lifespan of the bulbs, and we see which bulb will be, maybe which type of the bulb will be available maybe after, let's say, 6 months or 1 year, depending. So most of the times you'll find that the examiner is going to give you a question, but most of the questions that we do, we don't get it when it is very specific, to the point that they want you to draw a more than, or they want you to draw a less than or give, because the questions that follow, or the question that follows after we have constructed those, especially from the past paper questions, you find that they are not all that asking for how many are going to be, how many maybe are going to be above a certain value. So they are asking different things. That's why I've just wanted to highlight, you get to know that they are actually more than, and then the less than ogives. But it is just all about the class boundaries, whether you are taking the lower or you are taking the upper class boundary. So that's the main point. So the other that I want us to focus on are the steps. What are the steps that are involved in, of course, in drawing an Ogive, because that's the one that is very important. We want to look at how we can use the Ogive to be able to represent or to present a given data set. So let's look at the steps to draw an Ogive. Steps to draw an Ogive. Of course, the first step is to obtain the cumulative frequencies. The cumulative frequencies. The first step is to obtain the cumulative frequencies. Of course, how do we get the cumulative frequencies? We just, as long as we have the frequencies of the classes that we are given to us, then we can easily get the cumulative. It's just summing up the different frequencies depending on how they have occurred. So that's the first step. Of course, the second step is for us to draw and label the horizontal, to label the horizontal axis to represent of course the class boundaries. I'm saying class boundaries, but it depends on which Ogive you are drawing. Class boundaries and the vertical axis to represent the cumulative frequencies. And of course, the third step is for us to plot. The third step is for us to plot the points. But we always start with a point that is from the horizontal axis. So we plot class boundaries against the cumulative frequency. But most of the times, as I told you, we always take the upper class boundaries, because most of the times we always draw the less than. It's the less than that goes with the lower class boundary, because we always want to find that value that is going to be below a specified value. Of course, once you have plotted the other step is for us to join. We join the points. Join the points plotted. Join the points plotted by a smooth curve. I have to write this because someone may use a ruler and they just draw lines. We don't use line segments, but we use a smooth curve. Then of course the last part is for that the curve The curve should be joined the curve should be joined to a point on the horizontal axis, representing the actual lower class boundary of the first class So those are the steps that we follow as we be able to draw an Ogive. And as we said, we get the cumulative frequency, we draw the axes, and then we label them, with the vertical being labeled with the cumulative frequencies, and then the horizontal is going to have the upper class boundaries. So we want to pick maybe one practical question, then we look at it, and then we finalize the curves with the Lorenzo curve, and then we conclude the chapter. So let's look at a simulation example. The frequency table below shows marks of candidates in an exam, full stop. Then we have the marks, and then we have the frequency. The first one is 10 to 20, then 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70. Maybe you can stop there. Then this one is a 2, frequency 2, this is 8, this is 12, this is 18, this is 28, this is 22, and of course the required is for us to draw an Ogive to represent the data. So we get the solution, and of course we said that we start by getting the cumulative frequencies, and then we move forward to drawing the axes and then plotting the upper class boundary. But one thing I need to emphasize is that when they tell you to draw an Ogive, most of the times, as I told you, that we always take the less than. If the question doesn't specify, of course, most of the times the question will never specify. Most of the times, most of the questions that we see in the past paper numbers, they don't specify that you are drawing a more than or a less than. So we always assume that it is a less than. That's why we always take the upper class boundary against the we take the cumulative frequencies against the upper class boundaries. So the solution is for us to first get the cumulative frequencies. So these are max. And of course, you've heard that we are talking about class boundaries. But this, we've seen that this is what? The ones that we have are exclusive classes, whereby we don't need to compute we don't need to compute the class boundaries, because the class limits are always the class boundaries. So it is 10 to 20 and 20 to 30, 30 to 40, 40 to 50, then 50 to 60. The frequencies, this one they gave us 2, this one is 8, this one is 12, this one is 18, this is 28, and of course we have the last one. So now we get the cumulative frequency. Now, cumulative frequency, we always take the first one. That will be the first cumulative frequency. We take the first frequency to be our first cumulative frequency, because we are adding we have nothing. We have no values below that. Otherwise, it's like having a 0, then 0 plus 2. Now, when you are getting the second, for the second class, it will be the first class, which is 2, plus the second class, whose frequency is 8. And this will give you it will give you a 10. For the third class, we get 10 plus the frequency of the next of that class, which is a 12, and this will give you a 22. For the third, we take 22, which is the cumulative frequency for previous class, plus the frequency of the next class, plus 18, and this will give you a 40. Then you get the 40 plus the 28, and this gives you 68. Then of course we look at the other last class, because I've seen our class was stopping at let's check the question. Our class were stopping at 60 to 70, and it had a 22, the last one. So it was 60 to 70, and the frequency was 22. And of course the cumulative frequency for this last one is actually, we get 68 plus the frequency of the next class, which is 22, and that will give you a 90. So if the classes are stopping there, then we are done with that. Now, you have now to get the points. We need the upper classes. What we do, we just get our graph like this, and then we draw something like a 7, like what I told you last time. You draw a 7 like this, and we are taking all the values this side. But when we start to plot, we start plotting 20. Yes, we start plotting 20. And this 10 will just help us in the other step 5, because we said in the step 5, you draw the line to meet the horizontal axis, but it should meet the horizontal axis at the point of the lower class boundary, which is the 10. In other words, this 10 would be the next, would be our next class, our next upper class boundary in the class that is before 10. Maybe in a class, because these are 10, they are taking 10. So we've started from 10, but they are values before 10. In other words, the graph we are drawing, it's only giving us the values that are going to be above, because we start plotting from 20. So once you have identified the values, then you get the scale, the horizontal scale, and then you interpret it well. So let's maybe put our coordinates. Let's just summarize our coordinates that we are going to plot. We said we are going to plot starting from 20. 20 is our class, our upper class boundary. 20 with what is the cumulative frequency? The cumulative frequency is 2. Then the next one is of course 30 and 10. The next one is 40 and 22. The next one is 50 and 40. The next one is a 60 and a 68. Then the next one is a 70 and a 90, which is this 70 here and this 90 that we have got. So those are the points that we are going to plot. Once we have plotted these points, then we go ahead to join the points. But now you see, this is going to be on our x-axis. We need to get the scale. We can maybe use for both. We can say maybe 1 centimeter for vertical, let's say vertical scale, because they are all going, this is 90, our highest on the vertical, and in this one our highest is 70. So they are almost close. We can use the same scale. So for the vertical scale, we can say 1 centimeter to represent maybe 10. Of course, this is cumulative frequency. You can say units, but you just know that they are 10 cumulative frequency. So it means that one small square here, one small square is going to be equivalent to, of course, it's going to be equivalent to 2 units. Remember, we have said that the vertical scale is going to be equal to the horizontal scale. So we can say horizontal scale is equal to the vertical scale, which we have said it's going to be 1 centimeter to be equivalent to 10 units. So we can now go ahead to draw our graph. We draw and then we label the horizontal to represent our class boundary, and then the vertical to represent the cumulative frequency. So for me, I'm just going to label, but remember we always start from 0. But I told you we are going to, we drew that 7 form of a 7 in the other box, frequency distribution table. we said that we start from the 10. The reason as why we pull out that 10, even though it seems like it is a lower class boundary, is because we want to show the line where it will start from. This will be 10. Maybe this is 20. This is 30. This is 40. Of course, let me skip. This is 60. This is 80. This is 90. And maybe 100. So even this one, I can move this as well. Maybe 20. I start with the 20 here. Maybe this is a 40. This is 80. And maybe this is 100. Then we start our plotting. We plot starting from 20. This 10 that we put there is for us to complete our starting point. So we start plotting from the upper class boundary, which is 20. So 20 and 2, maybe let me assume it's around there. Then 30 and 10, 30 from the horizontal axis, then 10, maybe it's around there. Then 40 and 22, let me assume it's around there. Then 50 and 40, let me assume it's around there. Then 60 and 68, let me take it to be around there. Then we have the 70 to 90. 70 to 90. Let's assume it's around there. Now we join the points. First of all, we first join the points with a smooth line, not with a ruler. Just draw the line like that. Now the last, after joining the points, the last step is for us to connect the lower part, this part here, and we connect it to the last point of the lower class. This one is a number that comes from the lower class boundary. That's what we connect, and that's why we move like that and we stop there. So that's what we call the cumulative frequency curve. So if they want you to find any number, they may tell you to find maybe 66. If maybe they can pick any upper class boundary, then they tell you to find the number that is below that value. So that's the curve. And of course, we know that, especially when you look at the questions, the past paper numbers, you'll find that they are going to tell you to draw an Ogive, then they bring out questions. And these questions are going to be asking maybe for you to determine values. Just like the way I told you, if you are using the histogram, they will give you that. After drawing, then they give you some questions. They ask you maybe for the mode. Now this one, for it, we shall use it more often when we are dealing with maybe the measure of dispersion. where they can tell you to find the median and other aspects. But until we have maybe studied those, that's why I'm taking it slow and I'm not rushing to tell you to check the maybe past paper numbers, because I know once you get the concept, the past paper numbers are just, they are easy to do. They are very easy to do because we shall analyze most of the past paper numbers, and you'll see that once you know what to do, the rest are going to be okay. So that's what I wanted to talk about as far as the Ogives are concerned. So the next thing that I want us to focus on is going to be the Lorenz curve. Once we get the Lorenz curve, then we can be good to go. So that's the Ogive. But if you want to look at the illustration for a more than, this we said this is a less than. So for a more than, the difference is just how the graph looks like. For a less than, the graph can be like this, moving from maybe left to right, but not necessarily increasing, but you are seeing it is more moving the other side. But for a more than, you may find that they have given to you that, and it is moving maybe in this kind of direction, like that. You can find it when it is moving in that kind of direction, because most of the times they arrange that they arrange most of the questions that you may see, they arrange where you find that the first class has more frequency as opposed to the higher classes. The higher in the marks, the higher you go, the lesser frequency or the lesser items that are in. You may find that the frequencies are going to be in this perspective. Maybe they are 20, maybe 10, 2, maybe 1. So the moment you get the cumulative frequencies, you will see that the curve will look like as if it is moving this way. And most of the times this is not. Most of the questions that we find are in this kind of aspect, moving from, they are bending in the right hand side. So basically that's what we wanted to get as far as the Ogives are concerned.